Next, factors influencing rate of reaction. Here, 4 factors are there. One is nature of reactants, concentration of reactants, temperature, and catalyst. So these are the main factors which influence the rate of reaction. And enthalpy change delta H, it does not affect the rate of reaction. Okay. So here mainly 4 factors: nature of reactants, concentration of reactants, temperature, catalyst, and enthalpy change does not influence rate of reaction. Okay. And I will explain one by one. First, coming to nature of reactants. So coming to nature of reactants, rate of reaction depends upon the physical state of the reactants. Okay. So generally, rate of reaction of gases is more than that of liquids, which is more than that of solids. Okay. So coming to nature of reactants, rate of reaction depends on physical state. Okay. So gases shows the more rate of reaction than liquids than solids. And also it depends upon the size of the reactants. Okay. Smaller the size of the reactants, greater is the rate of reaction. Okay. Smaller the size of reactants, more is the rate of reaction. Okay. Then reactants which are in powdered state, they shows more rate of reaction, okay, than in the blocks form. Okay. In powdered state, surface area of reactants increases. That's why rate of reaction also increases. Okay. So rate of reaction is more when reactants are in powder state. This is due to increase in surface area. Okay. Then coming to ionic reactants and covalent reactants. So, you know that ionic reactions, they are very fast reactions and we cannot measure the rate of reaction. Why? Because ionic reactions, they completed within the fraction of seconds. Okay. And coming to reaction between AgNO3 and NaCl. We get NaNO3 and AgCl precipitate. So this is precipitate reaction, which is ionic reaction. And this is very fast reaction. Very fast reaction. Okay. That's why we cannot measure the reaction. Okay. And coming to covalent reactions. In covalent reactions, we observe bond cleavage and bond formation. Okay. So bond cleavage and bond formation both takes place. So that's why covalent reactions all are time consuming reactions. Okay. So for a bond breaking and a bond formation, time is required. Okay. So it takes some time. That's why we can measure the rate of reaction for covalent compounds. Okay. For example, En2 plus 3H2 gives 2NH3. This is formation of ammonia. So this is moderate reaction. Okay. So here first bond breakage takes place. N2 molecule, triple bond is present in between two nitrogen atom. It gets break first. And hydrogen having single bond. Okay. So with bond breakage, first bond breakage takes place. A new bond is formed in between nitrogen and hydrogen. For all this bond breakage and bond formation, time is required. So time consuming reaction. That's why we can measure the rate of reaction for covalent reactions. Okay. And we cannot measure the rate of reaction for ionic reactions. Okay. Next, coming to concentration of reactants. Okay. So concentration of reactants. So it is explained by law of mass action. Law of mass action. So according to law of mass action, which is proposed by Goldberg and Vogel, rate of reaction is directly proportional to concentration of reactants. Okay. As concentration of reactants increases, rate of reaction also increases. Okay. So rate of reaction is directly proportional to concentration of reactants. So this is according to law of mass action. So as concentration increases, rate of reaction also increases. So as concentration increases, rate of reaction increases. Okay. If reactants are gases, okay, gaseous substances are there, rate of reaction directly proportional to partial pressure of the gases. Okay. So for gaseous substances, instead of concentration, we use partial pressure. So rate of reaction directly proportional to partial pressure of gases. Okay. Next factor, temperature. So effect of temperature on rate of reaction, that is explained by Arrhenius equation. So you know about Arrhenius equation, that is in collision theory. Okay. So Arrhenius equation, what is Arrhenius equation? K is equal to A into e to the power minus EA by RT. Okay. So temperature dependence on rate of reaction, that is explained by Arrhenius equation. Okay. So effect of temperature on rate of reaction, explained by Arrhenius equation. Okay. What is Arrhenius equation? K is equal to A into e to the power minus EA by RT. Okay. So K is rate constant. A is Arrhenius factor. A, Arrhenius factor. This is also called as frequency factor. And EA is activation energy. And K is rate constant. Okay, or universal gas constant, and T is temperature. Okay, so here